Hi, everybody. Welcome to the FinOps on Azure podcast. Today I'm joined by a long-term friend of mine, Tom Kirkove from Belgium. Tom and I go way back in the integration community, working with Azure, but for quite a while, Tom's been working for Microsoft with the API management team. And recently I was looking at a blog post Tom wrote about some GreenOps related features in Azure API Management. And I reached out to Tom and said, look, can I grab you on the podcast and just have a chat to you about these features? Because I want to pick your brain about how they're working, why the team's building them, and that kind of thing. So welcome to the podcast, Tom.
Thank you very much for having me. I'm happy to talk about what we've shipped for helping our customers to reduce emissions.
Oh, brilliant. Can you just give people a quick sort of intro and a little bit of your backgrounds? Because there'll be a lot of people in the FinOps and GreenOps community who may not know you, but a lot of our integration community will be very familiar with you.
Yeah, so my name is Tom Kirkove. I'm a senior software engineer at Microsoft for Azure API Management for a little bit more than 4 years. Before that, I was a consultant at Codit for, I think, around 8 years, and a Microsoft MVP working with Azure and integration customers to build out the API platforms and SaaS platforms. And I'm the typical customer became engineer scenario. And I'm primarily working on our gateway and our self-hosted gateway. So we're trying to help you give you as much requests per second as we can.
So I think, so Tom, what was really interesting for me is as I've kind of got introduced and involved in the GreenOps community a little bit, there's certain technologies that tend to be more of the focus for people. And it was really interesting, your article, because API management wasn't necessarily something that immediately jumped to my mind as a one people would think too much about in terms of GreenOps. And I think especially FinOps as well, if it's like bar the SKU choice, there's not really the many knobs to dial and that kind of thing.
Exactly,
Yeah, so it's kind of taken a little bit for granted, but I think this is a really cool feature that you guys have got. Do you want to just give me a little bit of a sort of lap around what what the team are thinking?
Yeah, so let's start from a high level. So Microsoft, as a company, has ambitious goals to kind of reduce our footprint on the environment, and that was announced like right after I joined, and I thought that was very, very good. Like at that point in time, multiple companies had the same idea, and I was thinking, well, this is good. Maybe these companies set the theme for others to follow, and that started to tinker me like as an engineer, like what can I do? And I think 2 years ago, I read a book from O'Reilly, which is called Building Green Software, which I recommend people to read, which is focused on engineers, like why do we need to care? How can we kind of reduce emissions, etc. And then I took a step back and basically thought, well, I'm working on Azure API Management. What is our kind of key promise? We help you serve your API traffic, which means we're at the center of your API platform. So we can kind of, from that position, help you improve the impact of your platform. And if you have a look at it, there's three parts. So there's the client, there's the API gateway or AI gateway, and there's the backends. So the clients, you as kind of a platform builder, you do not control because they are your customers. But the other two, you do control. Now, to your point, API management as such will not have a major impact on your footprint. However, you're sending a lot of traffic to various backends, and those backends may be what needs to be optimized. And that is kind of problem one. Like, you have a platform. Now, how do you know what your impact is? And this is where Azure Carbon Optimization comes in. I'm not sure if you covered this before, but it's an Azure service that kind of explains you, based on your subscription or research group or whatever, where are all the emissions coming from. So that is a good kind of baseline, like before optimizing, does it get better or worse? And as part of this announcement, we announced 2 features. The first is in the policies that you write, you get access to the kind of the carbon emissions for the gateway itself, right? So this is what people in the green community call traffic shaping. You kind of shape the emissions for your traffic, which in this case means with the information we provide, you can decide to turn off features in the policy. For example, if you're doing audit logging to event hubs, which is not mission critical, you could decide, okay, let's stop all these non-critical audit messaging so that we reduce the pressure on the gateway, and hopefully we can scale in the gateway and thus have less impact. I usually compare this with what Teams and Zoom, etc., had to do at the beginning of COVID, where basically Teams was running out of capacity and they had to scramble to make sure they could still handle all the load. And what they did was they disabled small features like the type indicator, and that kind of gave them more headroom for the growing traffic. But what we did was more for kind of your optimization for emission. Like, you do not need this. We cannot, let's say, justify air quotes the emissions. So let's turn off XYZ and optimize this.
Yeah.
So that's the first part.
I guess the really interesting bit on that one, actually. So we had in a previous podcast 2 episodes ago, we had a guy called Jez back from the FinOps community, and he was doing this talk about something called cost of a click. What was really fascinating about it was in his team, they made this tiny sort of like 1 cent saving per click, effectively, or per transaction. But then when you scale it up to massive scale, that adds up to a huge amount, which is, I think, kind of the same idea here, isn't it? Where in API management, you might, for one request, you might think, actually, that makes no difference, but it's sort of hyper scale. It the compound effect of it's going to be huge.
Yeah. And that, like the at scale difference, is definitely something with the second feature that we have in a gated preview, which is kind of API management helping you reduce the emissions of your backends, where I call it a carbon up. So we have a built-in load balancer in API management. So when you create a backend, you can add multiple backends, and we will balance the traffic across these. Now, what we did was we basically carbon optimized this. And you can annotate your backend saying this runs in North Europe, this in Australia, this in Brazil. And now when we receive traffic for these, you can define, hey, I want to have at most, let's say, medium carbon emissions. If it is above that threshold, please don't route traffic to it. And what happens basically is the traffic will follow the sun in terms of the emissions. And when it is night time in Australia, it will send all the traffic to North Europe and Brazil. And as the sun passes, it will basically shift your traffic so that you kind of use the most green energy, but your backends can basically scale in the regions where there's no traffic. So, like I said, this works well if you have auto-scaling. If you don't have auto-scaling, please don't use it. You will have problems. But basically, you'll massively optimize the resources in these dirty regions.
Yeah. So I've got the blog article open, Tom, and I think because some of these concepts, I guess, for people who aren't as familiar, might be a little bit abstract. So I think it might be a good one for us to throw the article up on the screen. We'll kind of chat about this, and I'll just kind of get you to dig a bit deeper. So I think if we come down to this bit here, I think this
Yeah.
this section here is the kind of the second use case,
exactly.
isn't it? So if I just highlight this diagram here with my terrible arrow, so I think what you're seeing effectively is, and probably OpenAI is a good example. So if you're proxying an AI model, it's going to be quite heavy carbon usage for the model. And I think what you're saying is you've got the traffic comes into your API here.
Yes.
This is our API management. And then we've got these backends. So from the example you said before, during the day, we might route it to Australia. And then as the sun travels,
Yeah,
you might start routing it to Brazil and Europe as Australia moves into night. And I guess, am I right in understanding that in that example, obviously the energy production's more than just sun. So if we kept it simple, just said it's based on solar to begin with, that would be a really easy way of understanding it. But I think if I'm right, it goes a bit deeper than that, doesn't it? Because I think if we go down the article, so this.
So what you need to do is basically each of these backends that you define, which we saw at the top, you need to kind of attribute them with the Azure region that they run it, so that we know which data centers are they running and what is their kind of carbon footprint, etc. By hour. And then basically down below, you will see that in a load balancer backend here, this concept is not new, but what is new is the preferred carbon emission. Exactly. Yeah. So now you can say, I want to use this backend, and my preferred carbon emission is up to medium, because we have defined 5 carbon emission categories. So very small, medium, high, and very high. And that basically allows you to create buckets. Now, if the emission goes above category medium, this customer here is basically saying, please stop routing traffic to this backend because it is using dirty energy according to our standards, and we do not want to use it. Please route it to the other backend instead.
So am I right, with when we talk about preferred carbon emission, the added benefit there is, rather than in the simpler example before where we're saying as the sun moves around the world, the traffic will follow it, there's actually other complexities because not all energy is from the sun. So some countries might have wave and wind, and actually Microsoft abstract all of that complexity into just this preferred carbon emission value.
So we have hourly predictions per region, forecasted for 2 weeks in advance.
Right.
And because we want to make it simple, and also from a kind of a company perspective, we don't give these emissions directly, and that's why we offer you these 5 buckets to make it simpler to use.
And that bit I think is really important. So that was one of my follow-up questions, was about the, like, how frequently does this get updated? So what you're saying, I think, is you guys are forward planning what the emissions will be like in the future based on a number of assumptions, so that people can know how often they're going to move. So in theory, 4 o'clock it's running against Europe. We know that at 5 Europe would go to high. It'll get to, I don't know, say US, and then that's quite interesting.
That's correct. Like, we have these internal import jobs from API management side, where an internal data source, we pull the kind of the predictions on a daily, and this is where my integration background comes in, right? I used to do this all the time. So every day we pull the data, we massage the data, we make it available for our customers to make these decisions on. And this data source is the same as what Xbox is using, what Windows Update is using, where you will see, for example, in Windows Update that it is optimizing Windows updates based on your locale, and that is the same data source.
So how would it deal with things like, just to spitball ideas, let's say we had a weather event, and let's say a hurricane kicks off in the Caribbean, and 2 weeks out you're expecting that East US would be really good, but suddenly there's a big storm and it means it's not going to be sunny, it's going to be really cloudy. That might affect the use, like the carbon usage. How would that fit into the models that Microsoft are kind of planning?
That is actually something I cannot answer. That's why we kind of lean on this internal team that kind of preps the data for us.
Right.
But I'm guessing they do it purely historical and
Uh-huh.
based on kind of a retrofitting of data centers,
Yeah.
etc. Because we
But
keep on improving this.
yeah, but I guess over time, because you're refreshing the data as things
Yeah.
change, you would be picking up
Yes.
that
Yes.
kind of thing. So they again, I think from an end customer perspective, the good thing is that's all been outsourced for them. Microsoft internally treat that as a service you guys just consume, and over time, probably future Azure services will do similar things, I guess.
I cannot speak for other services, but that is definitely how it works for us, indeed. And we're looking for ways where, again, at the bottom of this article, people can sign up to give it a try. But we're also thinking like, how can we make this? How can we take this a step further? Like here, we're talking about carbon-aware load balancing for the backends. And the first feature I mentioned was using it in policies, which we'll see in a second. But using it in the policy is purely for the gateway itself. So one thing we're doing is why not combine two? And in the policies, allow you to kind of identify what is the carbon emission of your backend in the policy. So we're trying to give you more options to use so that it suits your needs.
So I think if we just take a second there, I'll just explain for the audience the difference between these two use cases. I think is really important because you kind of touched on that there. So I think what we're saying is use case number one about the routing is really where this bit here where we're dynamically routing traffic is really about optimizing, hitting the right one of these two boxes based on the most optimum carbon usage at the time. And then I think use case number two is much more about the internals of over here, where you're turning on and off certain features to.
As of today, yes.
Yeah, perfect. So let's drop down and have a look at that second feature. So I think this one here is the kind of building carbon intelligent policies. So
maybe before we go to this, so one more thing to add for the load balancing is imagine you want to define like the preferred carbon emission for all your backends. So what happens if they're all above the threshold, right? So that is why we call it preferred.
Right.
You prefer to have it, but if we know it will cause you a full outage because none of these backends satisfy the needs, we will not break your whole platform. We will basically say, okay, we know it's dirty, but we want to guarantee your traffic, so we will still flow it through. And fall back to the kind of the non-carbon optimized mode. So very important to know.
Yeah, and I guess that really touches back on a point you made earlier as well about making sure your backend's appropriate for this pattern as well. So it needs to support some kind of burst scale, and if you start routing everything to one data center as opposed to another.
Yes. So there is an Azure Friday episode coming if you want to see this in action, where you can kind of see, oh, now it starts routing to the dirty region, etc. But at the end of that, you can also see a screenshot where I did a load test with Azure load testing for like 24 hours nonstop. And you can clearly see how traffic kind of started routing for across these regions with millions of requests with no problems. And then it basically shows that thanks to the auto scaling, the compute basically was completely optimized. And this comes back to the point you mentioned earlier, is for a single request, it probably doesn't make much of a difference. But when you look at it like at scale, one day, 1 month, it definitely does make a difference.
Yeah, brilliant. So we drop back, I think it was here, wasn't it? So just talk me through this example on the screen. And so what are people really looking at here?
So now you can create carbon optimized policies, which is basically on the gateway itself. you can access information about the gateway's deployment and what the current intensity is. So here it uses the same, the buckets, the categories, like very low up to very high. And you can basically decide here, depending on the kind of the intensity, it switches the severity of the telemetry it writes, which means that when it becomes too high, it's going to, in this case, it's going to increase it to verbose because that is being kind of filtered out. But you could also just say, only trace this when the carbon emission is below high to kind of reduce all the compute for the to remove the additional compute that the gateway needs to serve all of your telemetry.
Got you. So if I just play back how I've understood that, then, so I guess for people who aren't API management familiar, we have an API request comes into API management here, and then this XML is really the policy that applies to that message. Yeah. So the message really goes, or the request goes through here, and then it'll come back out the other end as the API response. So I guess if we imagine it's a bit like this, yes. And this here is acting on the message. So I think what we're saying is, in this case, we've got a trace message here and here, and this is basically like an if statement in a way. So if the carbon's high, do one, and if the carbon's low, do another. And I guess the developer can then rather than just trace, they can do a lot of other things. So I guess maybe caching would be a good use case.
Yeah. So reducing telemetry is an example. Caching is another example. Reducing retries on backends is another one. Using circuit breakers. So all of these things is what you can do. We're by you introducing these, we're basically giving you the tools so that you can map what high or low intensity means for your API landscape. And what I was mentioning earlier is we're extending this. So as of today here, the intensity is purely for your gateway deployment, but now we're introducing the same carbon intensity information in the policy for all the backends that you've attributed with the region.
Right. Okay.
So you could do, like, if my backend has high carbon intensity, let's reduce the retries. We want to reduce the load, these kind of things.
So just so I understood that correctly then, so what we're seeing up here when we had the diagram was the routing pattern was really based on you telling API management which data center this box is in, and then API management would know what the intensity was in that data center, so not go to it or not. But in the policy, what you're really looking at is what's the intensity in the region, the node for the APIM gateway is running in. So there's a subtle difference there. Right.
So in the current state, you're either optimizing your backends with the built-in load balancer, and you're just saying these backends are in these regions, but we will handle everything for you.
Yeah.
And in the policies, you can optimize your current gateway deployments usage. But the next phase of our investments here is basically the combined way. In the policies, you will have both information about the gateway and also the backends that you've defined, which you may be using with the load balancer, or maybe not. But now you can also have this insights in the policy. So you will be able to do like a context.backend.sustainability.info.current intensity.
So would that be something I might use if I had like more of an active passive scenario where I might say, let's say I've got US and Amsterdam. So if I said I want to send my traffic to US all the time, but if that gets busy, sometimes I'd rather cache than go to Amsterdam instead, and I can like control that in a more advanced way. Right, that's really cool, Tom.
Yeah, because we have this built-in load balancing, but not everybody uses that. Maybe you want to do it yourself, such as you mentioned. And then the second part is also like if you want to be more gentle with these backends or reduce kind of features that this backend interacts with, you can also do that.
Awesome. And I think so for people watching, I think the key bit here is this bit of code here where you guys are sort of exposing that carbon intensity a bit like higher up, but you can access this in code yourself to do this if statement here. That's really cool. Can I ask one more question, Tom?
Yeah, sure.
So just talk to me a little bit about kind of the network routing a bit, and how, like in my architecture brain, how that's going to work. So if I have my API management, and let's say I've got users running an application in both the US and Europe again, so I'll be hitting what in my head's a central API management address. But then let's say we've got premium, so it has nodes in different regions, and then the backends could be in both the same region. So normally in my head it would be the user in the US hits the central API management URL, but that actually really under the hood hits the US node and then hits the US backend, and vice versa for the European ones. Is there any way you're going to control like which API management node they would hit? Because a good example would be the European guy hits the European API management node, but the carbon routes them to the US backend, and that to me sort of introduces other complexities, like the extra bandwidth, latency, that kind of thing. What do you think that impact is for people? And like, is that something you guys are looking at?
That is something we thought about. So when you create an API management instance, you get a DNS, and that DNS basically maps to Azure Traffic Manager. And that is basically routing traffic based on locale to your gateway deployments. So if you have a deployment in West Europe and US, here in Europe, you will get routed to Europe. Then based on the policies, it's going to route to whatever backend you've configured. Now, your question is one I've asked myself, like, can we make sure that instead of having API management that knows where to go, can we make sure it routes to the greenest region of the gateway directly? However, that is something we do not have because we depend on Azure Traffic Manager. So that is something they would need to support. And then you would basically resolve the DNS based on the carbon footprint, which I think would be a neat feature to have.
Yeah. I guess that's one of the things where there's a roadmap for these kind of things, doesn't it? So hopefully something like that might come along in the future.
Tom, the best thing to get this on the roadmap, as well as if you're a customer, raise this as a feature request.
Yeah,
and then that would help the traffic manager team to prioritize these things.
Brilliant. Tom, where's the best place for people to kind of follow you and look for more info on this kind of thing, and as you guys release new updates to this area?
So I would say if you're interested in this space, definitely follow our blog, which you can find here, and sign up for the preview. And you can find me on LinkedIn and X if you're interested.
Brilliant. That's great. Tom, I really appreciate. Sorry, I've just managed to muck the screen up there. I really appreciate you spending some time with me today. It's great to be able to grab a friend and just grill them a little bit on some of this stuff to dig deeper. I hope you got a lot out of that. Just being asked some questions by somebody who's a bit awkward at asking questions, and but hopefully we'll get a bit of airtime to this feature, because I think there's a lot of people in the community would find this really interesting. And as we were saying earlier, it's something I hope we start seeing in other stuff, other resource types on Azure, because it's really interesting.
Yes, I agree.
Thank you very much for your time.
Thank you.